Okay, so before I start this ninth lecture, two things that I want to mention. The first thing is regarding your assignment submission phase 1. We are still in the process of evaluating the makeup answer sheets. So give me some more time, maybe another 2 days, by which I'll be able to collate all your assignments, submissions, and I will prepare another list based on the submissions that has been done by you, and the same will be uploaded on the eLearn portal, right? So that we are clear about the groups that have been formed by you, or if you have made a submission individually, right? So this Excel sheet I should be able to complete and upload it by Tuesday evening or Wednesday morning. As soon as this information is collated, um, an announcement will also be generated on the portal. Secondly, the quiz 2 scheduled roughly in the first week of November. So an announcement regarding that will also be put on the portal. So these two things are in the pipeline. And subsequently, I'll also be posting the phase 2 of the assignment. Right, so these three things is what we're going to work on in the next 10 to 15 days in this particular course. Right, coming to the next question that has been posted as to how should we prepare for the comprehensive exam, which is going to be open book, what kind of a paper would be there. So you can largely expect more of case studies to be there, right? So it can be one complete case study for which you have to draw all the required UML diagrams and some associated questions on design patterns. Or it could be multiple small case studies, right? So maybe small case study in which you have to draw a certain set of diagrams, another small case study for a separate set of diagrams, another small case study for design patterns, right? Could be like that, right? But the idea would be that there would be no theoretical questions as such for which you can actually copy the answers directly from the book, right? So that is how an open book paper is designed. So it's more application oriented. So given a case, you are asked to draw the diagrams, etc. Right? Okay, so let us move ahead with today's lecture. We are going to continue with the gang of 4 design patterns. So in the previous lecture, we studied 3 design patterns which were a part of the gang of 4. The first was the factory pattern, then the singleton pattern, and then the adapter pattern, right? Today we are going to have a look at few more patterns. So I have in store today 4 patterns, and if the time permits, we'll complete all 4. Otherwise, at least 3 we should cover today. Okay. We're going to start the structural design pattern. One of the also uh, design pattern that we're going to see today is the okay. It's not my voice is breaking. Okay, give me a minute. Is it fine now? Hello? Can you just please type in? It's okay. I hope it should be okay. I am over a LAN. Okay. Okay, it's better. Okay, I'll increase the volume also. Okay, so there's a request to repeat what I said. So, uh, I was talking about the three things that are there in pipeline for this course. The first thing is that we have to take care of, that I have to take care from my side, is to upload the list of groups that you have created based on the submissions that have been done by you people. So that would be up by, say, Wednesday morning. The second thing is the quiz 2, which is again lined up for November. So I'll post an announcement regarding that as well. And the last thing is the phase 2 of the assignment. So the first week of November, you will also see the phase 2 of the assignment coming up. So these three things. Uh, that how do we prepare for the open book paper? Uh, you need to your open book paper will be based on case studies, right? So you will be given either a single case study or multiple case studies, and you would be asked to uh, draw diagrams and answer questions based on the given case study, right? So this is what we were talking about. Now I will start with the today's session, which is continuing with the gang of four patterns. And today we have a structural pattern which we will be discussing, and this is the facade pattern, right? Uh, I think now my voice is not breaking. I've started speaking slowly, right? So I think it would be better. I was very fast. Okay. So I've lowered my um, speech rate. Okay. So the facade pattern, it provides a unified interface to a set of interfaces in a subsystem, right? So this particular pattern, which is a structural design pattern and a part of Gang of Four, aims to provide a unified interface to a set of interfaces in a subsystem, right? So the idea is to define a high-level interface that makes the subsystem easier to use, right? So if there are n number of subsystems which the user is required to access and to interface with, this pattern suggests that you introduce a unified interface simpler to use and which in turn interfaces with the rest of the subsystems, right? Uh, yeah, so it is like a, for example, a travel agent, right? So a travel agent does what it the travel agent helps you or plans the entire trip for you, including a hotel booking, right? Flight booking, cab booking, right? So he's acting like a facade object. You need not yourself first book the tickets, then book the flights, then take up the cab booking process, right? So all this is done by a single person whom with whom you share your details, right? So you share all your uh, requirements with this particular travel agent, right? And he does the entire planning for you. And while sharing your travel or trip requirements with the travel agent, right? You tell him the days for which you are planning the trip, the number of people, the locations, your preferable list of locations, right? And maybe your preferable travel times, right? So some people want to travel in the night, some people prefer to travel in the daytime, right? So all this information is what you give to the travel agent, and he does all the booking for you, right? Obviously, he gives you a set of possible solutions, and then you choose from it, right? So this is kind of a facade pattern wherein this particular person uh, helps you in not accessing every subsystem one by one, but access a single system, right? Which has a unified interface, which in turn accesses the rest of the interfaces, right? Facade is a structural design pattern, right? So it provides a structural, um, a small additional structure which is put in on top of the various substructures that are there, so that your process becomes simple. Instead of one person accessing individual subsystems which have different interface, you provide a unified interface, which is a facade object, which you access through the unified interface, and this object further accesses the subsystems, right? I'll show you the diagrammatic representation for this particular design pattern. So it looks something like this, right? So this is my facade object that is created here, and it is responsible for accessing all the subsystems, right? So instead of putting a client here, which has to first access this particular system, then access this particular system, and then access this particular system, and then access this particular system, instead of doing everything one by one, you have a top level structure, a top level system, which provides a common interface, takes all the information from the user, and in turn accesses all the further subsystems and returns you the result, right? Okay. So I'll just come back to what is the facade object, the facade pattern, what is the problem that this particular pattern aims to solve. So there is a need for a simplified interface to the overall functionality of a complex system, right? So whenever there is a need for a unified, simplified interface to the overall functionality of a complex system, this is what overcome by the facade object, right? The solution is introduce a facade object that provides a single simplified interface to a more general facilities of a system, right? So the solution is introduce a common object which is called a facade object that provides a single simplified interface, right? We'll move to an implementation of the facade pattern and then understand it using that, right? Okay, there's there's a complaint that it's not audible. Let me just take off my mic and I'll plug it again. Give me a second. Okay, it should be fine now. Okay, fine. Okay, let's move ahead. Let us consider this example, right? So let's consider an example of a hotel keeper who's responsible for acting as a facade, right, for a five-star hotel which consists of 11 restaurants offering different kind of cuisines, right? So there's a hotel, it's a five-star hotel which has 11 different kind of restaurants which offer different kind of cuisines, right? A client approaching the hotel tells the hotel keeper about the different type of foods they would like to order, right? Now, based on the combined choices, the hotel keeper suggests the client the possible list of restaurants they should go for, right? This analogy is the one that has been derived from the recent kind of systems that you find nowadays, which, say for example, some sites like Trivago, right? So they help you uh, get information, or they provide you information from n number of hotels, right? So you are not required to visit the site of every hotel and look for the possible choices, right? What you give to the facade object, right? Or the in our case, in the example that we are discussing, say for Trivago, right? You give it the requirements as per your budget, your dates on which you want to travel, etc., and it does matching for you from all the websites, right? So I can see a lot of examples that are coming in, right? So Swiggy, Food Panda, etc. So all these are acting like facade objects for us, right? So this is how they help us prevent us from accessing a large number of subsystems, sub-interfaces, right? And they are providing us a unified interface, right? Okay, so I'll just take up a few questions. So they are not questions, actually examples. So Swiggy and Food Panda, Zomato, right? So these are all examples of websites which have actually acted as a facade object and help us, instead of accessing a large number of subsystems, they provide first-hand information through a unified interface, right? So, okay. This is what I have implemented here, a very small kind of a implementation just to make you feel how a facade object would be implemented, right? So let us move to the implementation slide. I think most of you have understood what actually the practical uh, scenario, what is that the facade pattern aims to solve, right? How does it solve that? So in this particular example, the restaurant that we are discussing about, so there is a common interface, which is a restaurant and which has a method get menus, right? So this is the main method that all the restaurant is supposed, all the different kind of restaurant classes are supposed to implement, right? So we have a Chinese restaurant which implements this particular interface and also provides interface implementation for the get menus method, right? So I'm not writing implementation for all the 11 different type of restaurants, right? It would be same. I've got for two more, so there might be some South Indian restaurant, there might be some North Indian restaurant. The idea is each of these class implements the restaurant method, sorry, the restaurant interface, right? And they provide the implementation for the get menus method, right? So in the get menus method, each of them create an object of their corresponding menu and return that particular object, right? Now let's see what does the hotel keeper does. Okay, I'll just zoom it a little bit. This should be fine. So the hotel keeper, right? So what the hotel keeper does, he takes as an input from the person who comes to that hotel the list of food items that they would like to order, right? So if for example, they might say that they want to order something like F1, F2, F3, and F4. So these may be the food items that they would like to order, right? We do not know what kind of food it is, right? So it might be Chinese, one would be South Indian, something would be North Indian, something would be another Chinese or something like that, right? So based on this input list from the customer, now it is the responsibility of the hotel keeper to tell the customer that which is the best hotel that which is the best restaurant that you should go to, right? So there might be a possibility that hotel keeper finds a restaurant which offers all these four foods, right? If that is not the case, then he would look for the restaurant which has the highest subset, right? And you would tell the customer that these are the items F2 or F3 or F4, and this is what they do not offer, right? So based on this particular list, another list of restaurants is generated and given to the customer. Right now, it is up to the customer which restaurant they would choose for. Right, so they might be able to find a restaurant which offers all the four types of food that they are looking for. Then they would go for that. Right, there might be a case that they may find n number of restaurants which offer uh, these four foods, right? In that case, they might look for the budget, right? So they might get the pricing and then see that which one is the best suited. Or there might be a case that they are not able to find a restaurant which offers all the four foods. So there is a restaurant, say R1, which is offering three of them and not, say, for example, F2, right? So now it comes to the customer. They might choose that, okay, we will adjust with another F1 instead of F2, and we would go to this particular restaurant, right? So this is how the hotel keeper acts as a facade object and obtains the information from the individual restaurants, do a unified, do a calculation of the given list and generates the result, right? A quick look at what the hotel keeper might look like, right? So, so this hotel keeper might have a method which says get the Chinese menu, right? So he might create an object of the Chinese restaurant and request to get the Chinese menu, right? Similarly, he gets the South Indian menu and also gets the North Indian menu, right? I've not written the implementation for the rest of it, but I hope you can understand it. So then the hotel keeper has more methods which take the food items as the list and return the required menus to the customer, right? So hence the hotel keeper in this case acts as a simplified interface between the multiple subsystems and prevents the user from accessing each subsystem, right, individually, and provides a unified interface, right? I'll just take up a few questions here. So does the facade only passes the information or executes something on behalf of the requesting process? So it depends upon the way you have implemented the pattern, the object. If you want the facade object to even execute something on behalf of the client who is accessing the facade object, you need to implement that in the facade object as well, right? So that depends upon how you carry out the implementation of that particular object, right? Ideally, it's a structural pattern that we are proposing that if you have certain objects, certain subsystems which are, if you have multiple subsystems in your system and the client is required to access all these multiple systems one by one, instead of that, provide a facade object which helps the client to access or even to modify whatever the chosen case may be, uh, the subsystems through a unified interface, right? So that's the idea. Okay, I'll just take up another question. So in this example, can the hotel manager take the order and arrange the food from different hotels and provide room service for the food order? So again, that depends upon how you implement your facade pattern, right? How you implement that particular object. If you want to implement it in this way that even places the order for you and provides you service, well and good, right? Otherwise, it just gives you a menu and then you can choose or so if you're manually there, you choose whichever restaurant you want to visit and then you go to the corresponding restaurant. If you're not manually there, maybe you want it to be delivered at your place or maybe you want it to be delivered in your room, then depending upon the implementation of the object, the same would be done. Okay, so this looks, another question, this looks tightly coupled with the number of types of restaurants. So if you have more restaurants that are adding up, so again these restaurants, all of them will implement the same method, the same interface restaurant and provide implementation for the get menus, right? So the hotel keeper will add uh, add the implementation to get instances of the new restaurants that have been added, get the menus for those interfaces for those new restaurants based on the get menu interface and add them to its list. I don't understand this question. Facade pattern is only for one object. We can't place any logic in facade since it's just an interface. No, it is just not an interface. It is a subsystem that you would create to be placed on top of multiple subsystems. So since it is required to uh, interface with a large number of subsystems, there will be a large number of methods that would be there in the facade object that you create. So it is not a single interface, right? But the idea is whenever you have to create a facade pattern, your subsystems must implement the same interface, right? And if you would have gone through the previous lecture slide, you would have found um, the idea that I have discussed there. We could not discuss in the lecture, but it mentions in the slides that uh, code for an interface, right? So in case all your subsystems are actually designed in this way that all of them code for an interface, right? It becomes easier uh, for later on. It becomes easier to implement the facade pattern on it, right? So in case each of the subsystem initially implements an interface, then you can actually easily make up a facade object on top of them, right? It seems that the facade object is working as a mediator for clients, could be considered as that way. Okay. There was one question that was asked in the previous lecture also, and would be uh, would be a good question to be asked today as well. Is that why do we always code to an interface and not provide abstract classes for implementation, right? So in all these patterns, if you see, uh, it's always said that we provide a common interface, right? And every other class implements that interface. So why can't we use an abstract class instead of an interface, right? The answer to this is in Java, you can implement n number of interfaces, but you can extend only one class, right? So in Java, you can implement n number of interfaces, but you can extend only one class. Now, if we ask you to, instead of using an interface, we convert it into an abstract class, right? Then my new class that I am creating would be required to extend that particular class. And additionally, if I want that particular class to implement, to extend another class, then you will not be able to do it, right? So there is only one possible class that you can extent, right? So therefore, you do not fill that one particular space that is there for extended classes, right? So that is why it is always that you say that all the objects which have a common interface should implement an interface instead of saying that they should extend an abstract class, right? I hope this is clear, right? Because we have only one slot for extending a class, and my class that I am going to write might be expected to implement another set of, might be required to extend another particular class. So I'm not filling that slot by asking that particular class to extend the specified abstract class, right? So that is the reason we always say that it should implement this particular interface, right? So because there are n number of slots for implementing the interfaces, right? I hope I make myself clear. Okay, that's it I have for the facade pattern. Let us move to the next pattern. The next design pattern for today is the composite pattern. Right, composite pattern is also a structural design pattern. The aim of the composite pattern is to compose objects into a tree structure to represent part or whole hierarchies. Right? So this pattern enables clients to treat individual objects or something called as atomic objects and their compositions, right? So there might be individual objects or there might be composite objects. Now these composite objects are also made up of individual objects, right? The idea is that this pattern enables clients to treat the individual or atomic objects and composite objects which are made out of these objects in the same manner, right? Let's understand this with an example. For example, consider a typical organization hierarchy, right? So there is a CEO, the head of the organization, right? The CEO has, say, n number of general managers working under him who are directly reporting to him. Okay. Also, the general managers have managers who are working under them, right? So there is a hierarchy. There's CEO, there's general manager, there is manager, right? Then each manager further has clerks working under him, right, who directly report to him. Moreover, there might be clerks who act as personal assistants who directly work under the CEO or the general manager, right? So we might have, say for example, a structure like this. So there is CEO, there are general manager, there's a general manager here, there's a general manager. The general manager, this particular general manager has a manager working under him. The manager has two clerks under him. This general manager has further clerk, one clerk also working under him. Then CEO also has a clerk working. The CEO has another general manager, and this general manager in turn has two clerks. Right? Important thing to notice here is that each of these objects, whether they are clerks, whether they are general managers, they are manager or CEO, each one of them is an employee of the company and is governed by the rules of the company, right? Moreover, in this case, if we see, the clerk is the atomic object, right? So it is a single atomic object of type clerk, of type employee, right? And it does not further has objects which are uh, which are composed within it, right? Whereas a general manager here is a composite object. It consists of further objects which are inside it. Now these objects which are inside this general manager could be either composite objects or atomic objects, right? Further, this manager is also an object which is a composite object, right? Just because he has further atomic objects placed inside him, right? So this is a kind of a part-whole hierarchy wherein you find atomic objects and composite objects placed within each other, right? The atomic objects always form the leaves of the tree, right? So it forms a tree-like structure. The atomic objects or the individual objects which do not consist of further objects, they always form the leaves of the tree, right? Whereas the middle nodes are made up of composite objects, right? However, it is important that each one of them is the employee of the company and is governed by the rules of the company. The idea is we want a pattern so that we are able to access each of these objects, whether composite or atomic, through a common interface, right? So let's see the problem that composite object aims to solve. How to treat a group or composition structure of objects in the same way as a non-composite object, right? So we want an implementation so that if it is either a composite object or a non-composite object, you are able to treat it in the same manner using the same interface. The solution is define classes for composite and atomic objects so that they implement the same interface, right? Again, here we find that the idea is both the composite objects and the atomic objects implement the same interface. Once they are able to implement the same interface, the client will be able to access the atomic object and the composite object using the same interface, right? This is what we have been saying in most of the design patterns that we have seen, that we provide for a unified interface and simply change the kind of implementation it does or maybe the way it is created, right? The whole idea is code for an interface, right? That makes the things much simpler, right? Once you are coding for a single interface, the interface becomes unified and you're able to access the objects through the common interface, right? So let's go back to our example and let's try and implement it. Just before that, so my composite pattern consists of 4 participants, right? I'll just show you the diagram of the composite pattern. So there is a base component, right, which is the interface. In this case, your base component, which is the interface, which all the atomic object as well as the composite object are required to implement, right? Then there are leaf components, which are your leaves of the tree, which are the atomic objects, right? These leaf components also implement the base component. Similarly, there is a composite component. Each of the composite components also implements the base component, right? Additionally, the composite component also has methods to add instances of the base component, right? Because it is a composite object, it can either comprise of more composite objects or atomic objects, right? As we saw in the previous diagram, at the general manager level, the general manager had a manager working under him as well as a clerk who was directly reporting to him, right? So that general manager, who is my composite object, comprised of another composite object as well as another atomic object, right? So in order to make that possible, I am including objects inside the composite objects which implement the component interface, right? This will become more clear as I'll go to the implementation, and then we can come back to this particular structure and see it again. So ideally, my composite pattern has 4 participants, right? The first participant is the component or the base component. It is the base interface for all the atomic as well as the composite objects, right? So my base interface is implemented by the atomic as well as composite objects. My leaf component is the one which is the atomic object, and this forms the leaves of the tree. This also implements the base component, and it represents the atomic object, and importantly, it does not contain a reference to other objects, and that is the reason it is an atomic object. It does not compose in itself other objects that implement the base component, right? Then the third important participant in the composite pattern is the composite component, right? So this is the composite component which consists of leaf elements as well as other composite elements, right? Okay, I've just written leaf elements. I will correct this. It can consist of other composite elements as well, right? It also implements the base component, and additionally it provides other operations in order to be able to access the components which are within itself, right? So it provides various child related operations. And then finally is my client participant. This participant is able to manipulate the entire tree using the base component interface, right? This was the description of the structure. Let's see an implementation of this pattern, and then we'll be able to understand it in a much better manner. So I've provided the implementation for the same tree that I had just shown you. I'll just go back to the tree once again. So this is the tree structure that I'm referring to. I've provided implementation for this, right? So there is an employee interface, and each of these implement the employee interface. I can see your hand raised, so in case you have any question, you need to type it into the chat, right? I cannot unmute you, so that will not happen. Okay, coming back to the implementation. So this is my base component, right? So this is my implementation of the base component. My base component is an interface which provides the required operations, which tells the required operations that must be implemented by every atomic object or composite object that implements the base component, right? So in this case, since we said that every atomic object or a composite object is an employee of the company, so the interface, and it is governed by the rules of the company. So in this case, for us, the interface of the rule of the company is that show employee details, right? So this one particular operation is one that should be implemented by each of the atomic as well as the composite object. This is my base component. Let's move ahead to the leaf component, right? So when we say a leaf component, so my leaf component is the atomic object, right, which forms the leaf of the tree. My leaf component in this case was a clerk, right? So at the lowest level was the clerk. The clerk implements the base object, right? So it implements the employee. Additionally, if you see here, it provides implementation for the method which is there in the employee interface. So this provides implementation for the show employee details. What does show employee details? It does. It prints out the employee ID and the employee name, right? Okay. Additionally, this clerk class also has two methods, which is the also has two attributes, which is the employee name and employee ID. Apart from that, it also provides implementation for the constructor of class, which takes in two strings, employee ID and employee name, right, and assigns the value of the incoming parameters to the attributes of the class, right? So this is my leaf component, which implements the base component interface. Let's move ahead. Coming to the composite component. So there's one composite component named manager, right? Again, this composite component implements employee, right? And if you see here, importantly, this composite component, right? So since it is a composite component, it consists of a list of employees, right? Since it is a composite component, it has to provide some way to compose or to add objects within it. So that is the reason it creates an array list wherein objects which implement employee can be added, right? And additionally, it also provides two methods, add employee and remove employee, right? So when you say add employee, it adds an employee to this employee list. And when you say remove employee, it removes the employee which is passed as a parameter from this employee list, right? Coming back to the implementation of our original method, which is there in the employee interface, which is the show employee details. So in this case, the manager composite object also provides implementation for the show employee details. What it does in that, it print out the employee ID and employee name, and additionally it prints or it invokes the same show employee details method on all the objects which are inside or which compose this composite object, right? I'll repeat here again. So in this show employee details method, which is implemented by my composite component class, which is manager in this case, it first provides the same implementation as the atomic object class was doing, and then it loops over all the objects that it is composed of and invokes the show employee details method for all those objects which are a part or which are inside this particular composite component. I hope it is clear, right? Similarly, you can have more type of composite components. You can as well have more type of leaf components, right? So in our case, we had only one type of leaf component, which was clerk. So I implemented only one class, which was clerk. You might have another leaf component, right? So you would add more leaf components. Similarly, for composite components, in this case, we have in fact, three composite components, right? So there is the manager who is composite component. Additionally, there is a general manager who is a composite component. And on the topmost level, there is a CEO who is another composite component, right? But all these composite components or atomic components, each of them is supposed to implement the base component interface, which is the employee, right? Okay, I'll take you to the implementation of the general manager class, which also implements the employee interface, right? And if you see, the rest of it is all same, right? It has an array list to compose within itself objects, and then it provides implementation for show employee details. It provides implementation for add employee and provides implementation for remove employee. Okay. Now let's see the last participant that would be there in a composite pattern is the client who would be using it, right? So this particular client, what it does is that it creates three clerks objects, right? So these are by individual or atomic objects. Three objects are created, right? The aim is to let me just go back to the pattern, to the structure. So what I'm doing is that I'm not providing implementation for the whole of it. I'm just working with this much hierarchy. Sorry. I'm just working with this much of the tree, right? So this part of the tree is what we are composing, right? So you need the CEO composite object also if you want to extend it to this particular implementation, the entire tree. I'm just working with this tree. I'm got an implementation here wherein I'm showing how to create this particular part of the tree, right? Okay. Let me go back to the client participant and let's see what the client participant is doing. Okay, so the client is creating three atomic objects which are clerks, right? Then it creates a general manager, right? In that tree, if you remember, the general manager had a manager inside it and a clerk who was acting as a personal assistant. So to this general manager, I add clerk 1, right? Add employee. Then I create another manager, right? And this manager had two clerks inside it, right? So clerk 2 and clerk 3, sorry, this should be clerk 3. So clerk 2 and clerk 3 are added to this particular manager. And then this particular manager, M1, is now added to the general manager, GM1, right? So you have the entire hierarchy created, the entire composite tree created, and then you can invoke general manager dot show employee details, right? So iteratively it will access and display the details of all the composite objects as well, right? You can even invoke M1 dot show employee details, so it will display the details of M1 and the ones that it is composed of. You can even invoke C1 dot clerk 1 dot show employee details. You can even invoke clerk 2 dot show employee details, right? So the same interface can be used on the composite object as well as on the atomic objects. Although the atomic objects are joined together to form the composite objects, but all of them together can be accessed using the same interface. I think that's it for the composite pattern. I will take up a few questions. For implementation of patterns, do we need to write complete code or pseudo code is enough? In case you would be asked to write the code, pseudo code is enough, right? So we do not go for any language specific solution that we might be looking for, but in case there are, then pseudo code will also do. So we need to prepare composite component within composite component. I don't really get the question, but if in case your composite component uh, need to comprise of composite component or atomic component, both are possible because uh, you have included an array list which takes objects which implement uh, the base component, right? So that could be either composite objects or atomic objects. Both can be added to that array list as long as both of them implement the same interface. CEO is a composite component which invokes GM, which is also a composite component. So we do not say which invokes GM, but composite CEO is a composite component which comprises of another composite component, which is a general manager. Right? So a general implement the employee interface, as well as the manager would be a composite component which would implement the employee interface. I think most of it is understood. We will take 5 minutes break here and we'll come back with 2 more patterns.